Alright, so we're setting up our overflow can. This time I'm going to measure the water directly into the graduated cylinder. Just like that. That'll save us a step. So I have here a clay boat. It was a 25-gram piece of clay. Let me confirm that over here off camera to the right. Okay, 24.96, we're going to call it 25 grams. And then we're going to use, we'll use some of these 10-gram, we're going to use some of these 10-gram masses right here. Now these are old, they've got probably some oxidation and some crud on them, but we're going to kind of keep things simple here, so we're going to use these. Alright, so the boat itself is going to displace some water. It has 25 grams. Archimedes' principle says that if it's the amount of water, whether it sinks or floats, the amount of water that it displaces is equal to the weight of the object itself. So let's check that out. We're going to put the boat in here. Notice it's displacing water. I don't want it to be stuck on the wall here, so I'm going to gently nudge it away and try not to displace any extra water. There we go. Alright, so let's check that water very carefully so as to not allow anything to drip out. So there's the volume of water right there. So it was about 25 grams. Let's tap that. So it's about 25 grams of clay. And hold on a second, let me get a good view of this. And we're at about 26.5 milliliters of water. You know, I didn't actually completely check that all the water had been drained from here. But we can see that there's definite correlation there. Slide that back under. Now I'm going to add 10 grams of weight. I'm going to be selective in how I add it here by putting it over here on this side to help balance things out a little bit. That's 10 grams. There's 20. There's 30. There's 40 grams of water. And I don't think I can add much more. It's hard to get it to balance in there, so I'm just going to let that finish dripping. So this has a total mass now of 65 grams. And it's going to start taking on water. So I'm going to quickly take a peek at this. And we are at about 69 milliliters. I am going to take this out. And I'll blot it dry. It looks like we took on a little bit of water right there. And so that has thrown off our value a little bit, because once that water seeps through and becomes part of the boat, it adds to the mass of the boat, which causes it to push down a little bit further, and that changes the mass of the boat. So when it has a leak, it sinks further and therefore displaces more water. And so anyway, there we go with the clay boat. If we build a better boat, we won't have leaks, and if we don't have leaks, that could be a little bit closer. With a little bit of water that came on board, it sank a little bit further, displaced a little bit more water, and put us up here at about just under 69 milliliters of water is what we ended up with. Okay, let that drip until it's done dripping. This time we're also going to be using the Lab Quest. Let's get this, wake this guy up. And the LabQuest is going to give us the force reading. So we've got a force sensor attached to it, and we've got a little homemade carrier right here that will screw into the base. In fact, I'll go ahead and do that now. It really is, like I said, it's homemade, so I just needed to fit in there. Normally there's a little hook that screws into the base so we can hang things from it, but we're not hanging anything. We're going to be pushing on it, so it'll take a pushing force as well. And I don't think we need that 50 newtons, do we? I think we'll leave it at 50 newtons just to make sure. Now we've got a little something hanging on it, which is this piece of metal itself, and we want that kind of to be ignored. It's kind of like tearing the scale here, so I'm going to zero that. And so that is ready to go. Let me do one more thing here before we do the racquetball, plunge the racquetball down, and that is we want to measure the diameter of the racquetball, because I'd like you to find the volume of the racquetball using the equation. Like for, you know, you've learned how to calculate the volume of different shapes. The volume of a sphere is 4/3 pi r cubed. So see if you can catch all this on the camera. I'll just kind of open this up until it just barely passes through the jaws, the calipers here. I feel like I'm squeezing it just slightly. All right. 56.1 millimeters, which is 5.61 centimeters. So from that you can calculate the volume, 4/3 pi r cubed. Your units will be cubic centimeters, and cubic centimeters are equivalent to milliliters. So we know the density of water is 1 gram per milliliter, which means it's 1 gram per cubic centimeter, however you want to figure that out. All right, now I'm going to tuck this in, so we are still at 0 when this is in its vertical position. I'm now going to tuck the racquetball into this, so it's already been designed to kind of fit in there, and this will slide over and keep it nice. And here we go. You can see it's got this nice secure fitting in here. And now we're going to plunge it down into the water. As we plunge it down into the water, we're going to capture the volume in the graduated cylinder, and we're going to try and read the force at the same time. So let's wake the LabQuest up here. There we go. Now it's reading a weight right now, by the way. This might be of note, of 0.43, 0.42 newtons. So that's the weight of the racquetball coming down this way. We're going to sense a negative force here as we plunge this down. And I want to do it slowly so that the water is captured in the graduated cylinder. Alright, now we're completely under. Notice the force is negative 0.50. It's done dripping, so I'm going to carefully bring this out. Set it down. And now we check the volume. Again, we had negative 0.50. Its weight was 0.42, if I remember correctly. And then it went to a negative 0.50, so the change in force from downward to upward is a net force of 0.92 newtons going up. And 0.92 newtons is, if we do the math, we'll maybe do this, you know, in post-editing here. If we do the math, we should end up with approximately 92 grams. And 92 grams is about 92 milliliters and 97.2 milliliters. So we'll do the math later and kind of do a comparison. But anyway, so there we go. We've done the 3 different trials. That'll be it.